is to illustrate simple and general annuities, to distinguish between simple and general annuities, find the future and present values of simple annuities, and compute the periodic payment of a simple annuity. Annuities. Simple annuity, according to payment interest interval and interest period. An annuity where the payment interval is the same as the interest period, that is simple annuity. While general annuity is an annuity where the payment interval is not the same as the interest period. So, simple simple annuity according to time of payment. So, ordinary annuity or annuity immediate, a type of annuity in which the payments are made at the end of each payment interval, while as annuity due is a type of annuity in which the payments are made at the beginning of each payment interval. So, according to duration, annuity certain, an annuity in which payments begin and end at definite times, while contingent annuity, an annuity in which the payment extend over or indeterminate length of time. Definition of terms. Term of an annuity, T. Time between the first payment interval and last payment interval. Regular or periodic payment, R. The amount of each payment, amount, future value, of an annuity, F. Sum of future values of all the payments to be made during entire term of the annuity. Present value of an annuity, P. Sum of present value of all the payments to be made during the entire term of the annuity. There are three formulas of ordinary annuities. The first one is the future value of simple ordinary annuity. Um, the second one is the present value of simple ordinary annuity, while the third one is the periodic payment R of an annuity. Um, the periodic payment has two types of formulas. The first one is if the future value is given, you need to use the top one, while if the present value is given, you need to use the bottom one, as you can see here. Um, so R is the regular payment, while I is the interest rate per period, N is the number of payment, R is the nominal rate, M is the number of conversion periods. Example: determine if the given situation represents simple annuity or general annuity. Payments are made at the end of each month for a loan that charges 1.05% interest compounded quarterly. It is general annuity because the payment interval is not the same as the interest period. Um, B. A deposit of 5,500 was made at the end of every 3 months to an account that earns 5.6% interest compounded quarterly. It is simple annuity because the payment interval is the same as the interest period. Example 2. Determine whether the situation describes an ordinary annuity or an annuity due. A. June monthly mortgage payment is 35,148.05 at the end of each month. It is ordinary annuity because um, it's the type of payment that are made at the end of each payment interval. While B, the rent of the apartment is 7,000 and due at the beginning of each month, is annuity due because it is the payment that are made at the beginning of each payment interval. Example 3. Suppose Mr. Moto would like to save 3,000 every month in a fund that gives 9% compounded monthly. How much is the amount or the future value of her savings after 6 months? The given are R equals 3,000 pesos. The time is 6 months. The rate is 0.09. While the month is equals to 12 because it is compounded monthly. So we're gonna get the n by multiplying 12 and 1/2, so it will result to 6. So we're gonna get the interest by dividing the rate and the month. So 0.09 divided by 12 divided by 12 is equals to 0.0075. So find the future value. Let's find the future value by using the future value formula. So 3,000 open parenthesis 1 plus 0.0075 close parenthesis to the power of 6 and minus 1 divided by 0.0075 or over 0.0075, so it will equals to 18,340.89 pesos. Example 4. In order to save for her high school graduation, Mary decided to save 200 pesos at the end of each month. If the bank pays 0.25% compounded monthly, how many will her money be at the end of 6 years? So the R equals to 200 pesos. The time is 6 years, while the rate is 0.0025 and the M is 12. So we're going to find the number of payment by multiplying M and T. So 12 times 6 equals to 72. We're going to find the interest rate. We're going to find the interest by by dividing R and M. So 0.0025 over 12 is equals to 0.0025. So yeah, let's find the future value. We're going to find the future value by using the formula and the future value. So 200 open parenthesis 1 plus 0.0025 over 12 and minus 1 over 0.0025 over 12. So the answer is 14,507.02. Rose works very hard because she wants to have enough money in her retirement account when she reaches the age 60. She wants to withdraw 36,000 every 3 months for 20 years starting 3 months after she retires. How much must Rose deposit it at retirement at 12% per year compounded quarterly for the annuity? Given R equals 36,000, time is 20 years, R equals 0.12 and M equals 4. So the number of payment is 80 while the interest is 0.03. Let's find the present value. 36,000 plus 1 minus open parenthesis 1 plus 0.03 to the power of negative 80 over 0.03. So we can get the answer 1,087,227.48 pesos. Example 6. Mr. Ibaya paid 200,000 as down payment for a car. The remaining amount is to be settled by paying 16,200 at the end of each month for 5 years. If interest is 10.5% compounded monthly, what is the cash price of his car? Also, I forgot to mention the cash value or cash price of a purchase is equal to the down payment if there is any plus the present value of installment payment. So given is down payment equals 200,000 while the R is 16,200. The rate is 0.105 and the time is 5 years and the month is 12. So the number of payments is 60 while the interest is 0.00875. So let's find the present value. 16,200 1 minus open parenthesis 1 plus 0.00875 close parenthesis to the exponent of negative 60 over 0.00875. So it equals to 702.20. So the cash price is equals to D plus M or down payment plus present value. So 200,000 plus 753,702.20. So and the cash price is 900,000. 953,702.20. Example 7. Paulo borrowed 100,000. He agrees to pay the principal plus interest by paying an equal amount of money each year for 3 years. What should be his annual payment if interest is 8% compounded annually? So the given is P equals to 100,000 and the rate is 0.08. The time is 3 years and the M is 1. The number of payment is 3 while the interest is 0.08. Let's find the periodic payment. So 100,000 over 1 minus open parenthesis 1 plus 0.08 close parenthesis negative 3 to the exponent of negative 3 over 0.08. So the payment is, so the final answer is 38,000 803.35 pesos.